All right, now it's 6.3b is going to be writing equations in polar and rectangular form. So we're going to be going from polar to rectangular and vice versa. First, a polar equation is going to always have variables r and theta. Okay, so you want to make sure that your equation is always going to be r equals. Always r equals. Okay, so this is super important. That's how you know we are talking about a polar equation. So these are some examples that we have for you. Please note that they all have r equals and the variable is theta. There should be no x's and y's when we're talking about polar equations. Now with rectangular equations, it's the opposite, right? These are the ones we're used to. So these have x's and y's. X plus y equals 5, x squared plus y squared equals 16. This doesn't necessarily need to say x equals or y equals, but that is more what we're used to. As long as there's no r and no theta in our final answer, we should be good to go. So you are going to need to go between these two forms. Thankfully, these are some important things to help you out. And these are found in your golden ticket, okay? So you do not need to memorize these, but you need to be able to identify them so that you can go back and forth between forms. Anytime you see an x, you can replace that with r cosine theta and vice versa. Anytime you see a y, you can replace it with r sine theta and vice versa. This one's going to be a really popular one that we're going to use. So r squared can be replaced with x squared plus y squared. Same thing the other way around. And then tangent theta, we're not going to use it as much, but it is still there. Okay? So the first part of the notes will be to convert from rectangular to polar. Again, I'm going to make a side note, your polar should be r equals, and there should be some thetas in your final answer. If there's any x's and y's, you are not completely done. So think about how you get x to be in terms of r and theta. So x can be replaced with r cosine of theta, right? So we can just replace that. That's an identity. It's a property. So we're good. And that equals -7. In order for me to solve for r, this is still just regular math, and these are being multiplied, I can divide both sides by cosine of theta. So final answer, r equals -7 divided by cosine of theta. A good check would be, are there any x's and y's left? Nope, and so you are done. That is all you have to do. For number 2, this is another property right above. We can replace x squared plus y squared simply with an r squared. So this is r squared equals 16. And you want your final answer to just be r equals, so I would have to take the square root of r and do the same to the other side. R equals 4. Now, it's important to note why I don't say plus or minus. I'm thinking about what r stands for. R is radius. You can't have a negative radius. You also can't have a radius of 0. You need to have something to have a radius, so that's why we only include the +4 value for this one. Okay? And the next one, we have to first simplify the way this looks. I'm going to do that by multiplying out the x minus 1 squared. So this means multiply x minus 1 times x minus 1, do double distribution, and so on. That becomes x squared minus 2x plus 1. Then I'm going to bring down the plus y. That's still there, but that's a y squared, and then the 1 there. Here's where you need to get creative or rearrange it if you want. We know that x squared plus y squared is going to equal r squared, right? So I can actually get rid of those and just say r squared minus the x I can replace with r cosine theta. So I'm going to say minus 2 r cosine theta. And I still have the plus 1 there. So plus 1 equals 1. Then I can subtract the 1 over. That's going to cancel out on both sides. So I have r squared minus 2r cosine theta. And then seeing what else can I do here to get this to equal r. I can factor out an r from both of these terms. And when I do that, I get r minus 2 cosine theta equals 0. So this is kind of going back to solving our equations. R equals 0 and r minus 2 cosine theta equals 0. So this, if I add the 2 cosine over, I get 2 cosine theta for r, and I also get r equals 0 over here. Well, we just talked about how r can't be 0. We need to have a radius of something. We can't have a radius of nothing. And so then my only equation in this case would be r equals 2 cosine theta, and that's it. Now we're going to go the other way. So we have to make sure we're using these equations to convert from polar to rectangular. Anytime I see x, I would replace it with r cosine theta. So same thing with y, r sine theta. I need to make sure that my final answer, because I'm going to make them rectangular, only has x's and y's. So you may need to manipulate the way the equation looks to make this happen. So let's get right to it. The first one, we have r equals 5. So think about, how can I take this r and make it in terms of x and y if I needed to? Well, in order to do that, I need this to be an r squared. So what I'm going to do to the entire equation is square it. We can do that as long as we do it to both sides, right? When I square this completely, I get r squared equals 5 squared. This is the only property. I don't have one that says r equals a single term. That's why I have to square the whole thing. So r squared is going to change to x squared plus y squared. And that equals 25. And we are not looking for a particular like y equals answer or x equals. As long as there's no more r and thetas, you are good to go. The second one, we have r equals 3 cosecant theta. I'm going to use this property that cosecant is the inverse of sine. So r equals 3 over sine of theta. And again, we just want to make sure that things are in x or y. So I'm going to make this look like r sine theta by multiplying both sides by sine. Okay, so when I do that, all I have left is 3 over here, and on this side I have r times sine theta just switched around, and this can be replaced with a y equals 3. And that's your answer. Okay? And we're going to go a little bit out of order and solve number 4 first. So same concept of, I can't do anything with just r by itself, but I can do something if it was r squared. I'm not going to square the whole thing this time because there's more stuff going on. Instead, I'm going to multiply by r to the whole thing. So that's still going to give me an r squared on the left, and in the middle, I'm going to get 12 times r cosine theta. You can write that in a different order, but hopefully this helps you see that r times cosine can be replaced with an x, which eventually I want to get just x's and y's. And the r squared is x squared plus y squared. Okay, so I'm getting a little bit closer. Now, for particularly why you square both sides or multiply both sides by r will just depend if you have more going on. So in number 4, I had cosine involved, and I know that r times cosine can be changed to an x. That's why I chose to do that. If I squared the whole thing, cosine squared is not really going to help me change that to an x and a y. So that's why we're doing it. Now we want to try to simplify this a little bit more. And so I'm going to subtract the 12x over to the left. Okay, so this equals 0, and I'm going to write them next to each other. Y squared minus 12x plus y squared is here. Now, in this case, we want to simplify this by using what's called completing the square. Okay, and it may be a while since you oops, the square, last did this. But essentially what we have going on is a quadratic. I'm going to kind of scribble over here on the right. We have a quadratic with no c term. And so what we want to try to find is a perfect square that's going to help me factor this out a little bit nicer. So in order to complete the square, I have to add b over 2 squared to both sides of the equation. Your b term is just the number next to the x. So in this case, my b term is at negative 12. To complete the square, I'm going to take negative 12 divided by 2 and square that. So that gives me negative 6 squared is 36. This 36 value gets added to both sides of the equation. Okay, so to both sides. So I'm going to go back to my formula and I'm going to add the 36 here and here. So I really have x squared minus 12x plus 36. I still have the plus y squared. And then instead of just 0 on the right, I have 36. Okay? Now this makes this problem factorable. I am able to factor this. And that gives me x minus 6 squared. The whole point was to create a perfect square. So what number multiplies to 36 but adds up to negative 12, negative 6, and negative 6? I can write it as one term because it's the same thing. Then I still have the plus y squared and then equals 36. Okay, and that's my answer there. Now, earlier I said that there wasn't a particular way we wanted your rectangular equation in. Not necessarily true, so I want to make sure we go back to the beginning of the notes. Please note how the rectangular equations are written as x term plus y term equals, x term plus y term equals. That's why we had to get creative with this very last example. That's why I couldn't just stop here in this step. We couldn't stop there because we still had multiple x terms and y terms on one side of the equation. So my apologies, there is, I guess, a specific way to do that. We didn't necessarily need to do that with examples 1 and 2. It just worked out nicely where I had the x squared plus y squared. So again, x term plus y term. And then number 2 doesn't have multiple terms. So that's why number 4, I have to do a little bit more work and can't stop at that point and have to make it so that it's only one x term being squared and then the y squared next to it. Okay? Now, number 3, we're going to do the same thing. Again, it wouldn't just help me to square both sides like I did for example 2 because sine squared is not really a property going from polar to rectangular. So instead I'm going to multiply both sides by r so that I'm still creating that r squared, but it also helps me get rid of the sine. So this is r squared on the left and this is r times sine theta on the right. This is a property. This turns into y. And this will turn into x squared plus y squared. Now, same thing, I need just one x term plus one y term in my equation. So what I'm going to do this time is I'm going to subtract the y over this way. So I have 0 on the right, and this leaves me with x squared plus y squared minus y. So I'm going to focus here. This is the part of the equation that I have to convert to one term, like I did in example 4. So in order to do this, I need to complete the square again. Okay. In this case, my b value is a -1, so I'm doing -1/2 squared, and that's going to give me 1/4. This is what you're going to add to both sides of the equation. Again, for completing the square, I'm following this formula, I guess you could call it. So whatever is next to the x term, divided by 2 and square it every time. That's like a formula you do. And then you're going to add it to both sides of the equation. So when I add 1/4 to both sides of the equation, I still have x squared over here. And then I have y squared minus y plus 1/4. and then I'm adding the 1/4 over to the right. I have to do it to both sides of the equation because that means I'm not changing anything, okay? It just helps me factor. So from here, we're going to factor this trinomial. And again, the whole point is to get the same term being squared. So you get y minus 1/2 squared here. The 1/4 is still over here, and we still have the plus x squared. I know that I'm done because I have an x term plus a y term all together, and then that equals a constant, so 1/4 in this case. Again, I would not be able to stop at this point because there was just too much going on, or even here. There's still multiple y terms, and I have to consolidate them to just be one y term and one x term in the equation. So then this is my final answer. Again, checking that I'm done with just one of each term. And that is your final answer and the end of your notes.